This video is part 2 of the discussion about context configuration in the Topology as a Service framework. Part 1 discussed the general characteristics of context configuration and presented the first example of a 3-tier Java EE application. Here we continue with a second example using REST services, including interactive demonstrations based on sample implementations. The general explanations regarding context configuration have already been discussed in part 1. The according slides is just included as a reference. Let's focus here on the second example. The second example that we want to look at for context configuration is a Java EE web tier calling a REST service tier. Again, we look at how context is added during provisioning here. The load balancer is pretty much the same as in the 3-tier example. It has to call the servlets in the web tier, so no difference here. But in the Java EE presentation tier nodes, we have the dependencies that every outgoing REST connection's destination node must be instantiated again so that the dynamically generated host names are known. So that's pretty similar to the HAB dependencies. And the actual context configuration is very similar as well. Remote commands are returned to set up the JNDI tree on the target servers to include the REST connection's destination nodes. Again, through the mechanism of foreign JNDI providers. Note, Java EE unfortunately does not have a standard annotation for REST service reference injection and no standard principal to JWT or JSON web token conversion. So TaaS has to add these capabilities itself to make REST usage as simple as HAB usage for applications. We see that in the deployment task discussion much better. The Java EE REST service tier nodes are not affected because here we restricted it to not call out to anything. It's just standalone. To add deployment context for this example, we look again at the application's code first. There's a client servlet, a simple one that does nothing else than call a REST service. And in order to do that, it has to inject the RS-based URI client, which is a TaaS edition, to get the name of the service from somewhere and create a base URI local variable that implements the RS-based URI as service API. The rest is pretty much standard to create a connection to a REST service. The client builder is involved. We have to build the client first and register in order to fulfill the security requirements, register the JWT caller request filter, get the URI string of the target from our injected base URI, set the path, the media type, and so on, and get the result. On the other hand, the implementation of the REST service, in this case it's also a servlet, it publishes the service properties that the client will need to inject the base URI. So it has to add an annotation to the servlet class that says I'm a base URI server that publishes the name of the service and, by the way, the port as well. Then within that servlet, the getHTML method, which will be called from the REST system underneath, will get called, and it will have the annotation JWT callee in order to set the security principal according to the token that was propagated with the call. So let's look at the various nodes and what they have to do. For context configuration, again, the load balancer is not affected. In this case, the presentation tier nodes, however, they have the dependencies that every outgoing REST connections destination node must have its deployment artifacts installed, which means the REST service name and port are published in its JNDI tree. Only then can we actually do the context configuration, which consists of remote commands that set up the needed JNDI links, similar to the HAB set up before in the node's Java EE server. The RSpace URI client annotation is a TaaS addition to support the services space URI injection from the server's published service properties. And the JWT caller request filter is again a TaaS addition to support client principal propagation via conversion to JWT. And in the REST service tier nodes, we don't have to do anything again because they are not calling out to anybody. However, the node says that the RSpace URI server annotation is a TaaS addition to publish the service properties in the local JNDI tree to support the RSpace URI injection in the clients. And secondly, JWT callee annotation is a TaaS addition to support principal propagation via JWT in the server. The second example to demonstrate context configuration in Topology as a service uses REST implementations or REST service calls. For that, we have a predefined topology that has two elastic nodes. We make them both scalable. Let's set the first one initially to 2, and the service implementation tier scalable as well, but leave it at 1 first so that you can scale it later. That creates the topology that we need with a load balancer in front that can actually do REST or HTTPS. We use HTTPS to the servlet tier, the web tier, that itself does a REST call to a service implementation tier in the backend, which is elastic as well. Currently we have 2 nodes allocated in the web tier and 1 node in the service tier. That shouldn't take too long to instantiate. As in the HAB example, the context configuration that's happening during provisioning is the setup of a JNDI tree for an extended namespace between the nodes in the web tier and the nodes in the service tier. That took 53 seconds. That's okay. Now let's deploy a sample application that tries that out. That would be this one. We instantiate it and deploy it. The first artifact is the client, a regular servlet that does a client call to a REST service using the Topology as a service additions to inject the dynamically created URL to the service implementation. Same thing for the second artifact that gets deployed to the service tier. It's the actual implementation of the REST service within a servlet this time, using again the extensions from Topology as a service. That already happened, so let's see how that works. Can call it directly through the load balancer on the first port again. What happens, the servlet gets called, writes out its host name and its principal, which is established through through the certificate exchange with the client's browser. And it writes out the result of the call to the REST implementation, to the service, which only returns again the host on which it is running and the principal it is running on. So if we reload it, we had clone 1, reload it, and it's going to the first node in the web tier. And it remains with the same node in the implementation tier because there's only one. So let's change that. Scale it up to 2, which will create a second node inside the service implementation tier. Will then again set up a JNDI tree or a foreign JNDI provider in the presentation tier nodes to that new service node, and will finally deploy again the service implementation and set up the JNDI link in the deployment to the new service. So that took 38 seconds to scale up the presentation tier. Let's see to scale up the service tier. Let's see what happens with the demo. Goes to clone 1 in the presentation tier and still the old node in the service tier. Let's try again. Goes to the first node in the web tier and still the old node in the service tier. Let's try again. It goes to the clone 1 on the presentation tier and this time to the new node in the service tier. Try it again. Goes to the first node in the presentation tier and again to the clone 1, the new one in the service tier. This happens actually because the Topology as a Service extension for REST services does a load balancing in every call going out from a node in the presentation tier to the service implementation. Which means in every node a round robin happens to the service implementation nodes in the service tier. We can see that by being faster than the round robin timeout in the load balancer, in the hardware load balancer, by going to the same node each time. So let's refresh, goes to clone 1, refresh quickly, goes still to clone 1 in the presentation tier and cycles through the service implementation nodes in the service tier. So that's the load balancing that's happening in software within the presentation tier nodes. Once we are done, we can get rid of the whole installation again. All the side effects are removed and we are clean again in the same state as in the beginning.